Hello guys, in this video I am going to explain you how to solve this particular circuit to determine the Thevenin equivalent network across these two terminals A and B, right? So again, to determine the Thevenin equivalent circuit, it simply means that we need to have this type of circuit. This is VTH, this is RTH, and these are the two terminals A and B, right? These are the two terminals. Over here A and B are this, right? So across A and B terminal we need to determine VTH and RTH. And similar to the last video, over here to determine, first we are going to determine RTH over here. So to determine the RTH, what we need to do, we need to deactivate the voltage sources and the current source. For voltage source, if we are deactivating voltage source, it simply means that we are going to replace this with short circuit. And to deactivate current source, we need to replace it with open circuit. So let me redraw this circuit. So over here, if I redraw this particular circuit, so it will be like this. A, B, it is 5 ohm, it is 2 ohm, it is 3 ohm, right? Over here, this voltage source will be deactivated, means I replace it with short circuit, right? Now this is the current source, this will be deactivated, means it will be replaced with open circuit. Then we have this 1 ohm, and now this voltage source, it need to be deactivated, so it will be replaced with short circuit. Now after having this circuit, now I need to determine RTH through this AB terminal. So it means if I remove this open circuit wires, just to simplify, so it will look like this, right? So the first thing that we can do, we can determine just a minute. Yes. So we can see that this 1 ohm and 3 ohm, they are in parallel to each other. So what we can do, we can determine the equivalent resistance for this 3 ohm and 1 ohm. So the equivalent of this, it will be R equivalent 1 is equals to 3 into 1 upon 3 plus 1. So it will be 3 upon 4, 0.75 ohms, right? Now this circuit can be redrawn in this form. Right? And this is 5 ohm, this is 2 ohm, and this is 0.75 ohm. These are equivalent. Now you can see this 2 ohm and this 0.75, they are in series with each other, right? So it simply means that we can combine this 2 and 0.75, so we get 2.75 ohms, right? So it means we can modify this circuit by, and in the modified circuit we will just have this, and it is 2.75 ohm. And now 5 and 275, they are in parallel, so we will determine RTH as 5 into 2.75 upon 5 plus 2.75, right? For this formula, like it is simply this formula that I am using, right? If you take the it is 2.75 plus 5, and the LCM is 5 into 2.75. So since it is 1 upon RTH, so if you simplify it, you will get this form, right? So let me erase this one. So it is equals to 5 into 2.75 upon 7.75, and for this our RTH, it will be equal to 1.77 ohm. So this is our RTH, right? So let me put the value over here, 1.77 ohm, right? Now we need to determine VTH. To determine VTH, I told you in the last lecture, in the last video, I told you that we need to determine this voltage, plus minus VOC. Somehow we need to determine VOC. To determine VOC, we can use any theorem. So let me use the mesh analysis. So let this be one current loop, this is second loop current, and this is third loop current. And now since the first and the second loop current, like we have a current source over here, so the first and the second forms a super mesh, right? So I am going to write the loop equation for both 1 and 2 for this and this together, right? So starting with this 2 volt, so I take it as plus 2. Then over here we have only I1, plus over here, minus over here, so plus 2 minus, so again it is 2 I1. Now after this I come to this 5 ohm, it over here plus minus, and the current is I2, so it is plus 5I2. Then I come to this I3, right, plus minus, and the current, this current is I2 minus I3, so it will be 1 I2 minus I3 equal to 0. So this is our first equation, right? Now the second equation will be formed by considering this is a 2 ampere, and the current, like considering I1 and I2, in terms of I1 and I2, the current will be I2 minus I1. So I2 minus I1 will be equal to 2 ampere, because in this particular branch in which we have 2 ampere, so I2 is going up, right? I2 is going up, I1 is coming down, so overall it will be I2 minus I1, right? Now considering the third loop, this I3, so over here starting from this, it is plus minus, right? So plus to minus, and the current is I3 minus I1, so it is 1 I3 minus I1. Then over here it is I3 plus minus, so it is plus 3 I3. And then over here it is plus 2 minus, so plus 4 equal to 0. Plus 4 equal to 0. Now if you solve these three equations, if you simplify these three equations, over here you will get I1 as minus 1.87, I2 as 0.13, and I3 as minus 0.97 volt, right? And now coming back to this circuit, if you look at, let me erase some part, just this is the I2 current, right? In this from this through this 5 ohm only I2 current is flowing, right? And plus is over here, minus is over there, so it means our VOC, it is equals to the voltage drop across 5 ohm, which is 5I2, right? So we get I2 as 0.3, so it means 5 into 0.13, we get 0.65 volt, right? So this is our VOC, which is also our VTH. So our VTH, it is equals to 0.65 volt, right? So 0.65 volt. So this is the solution to this particular question, in which RTH we got 1.77 and VTH we got 0.65. Over here again, since we have only independent sources, so independent sources are deactivated and we find RTH, and then we somehow determine VOC by using any other theorems or KVL, KCL, and then once we determine VOC, it is our VTH. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.